Okay, we're on lesson 114 to start. So you're going to do the evens on lesson 114. And this is talking about more on simple probability, but it's on probability of more than one event occurring. So it says we're tossing a fair coin. A fair coin means it's not weighted on either side. So you have, if you're asked for the probability of tossing the coin and coming up heads, it would be 1 out of 2 because there's one head out of 2 faces. So this one wants to know what is the probability that it will come up heads on every time if you toss the coin 3 times. So what is it for the first time? It's one head out of 2 sides. Times, what is it for the second time? 1 head out of 2 faces. Times, what is it for the third time? 1 head out of 2 faces. So that would be 1 times 1 times 1 is 1, over 2 times 2 is 4, times 2 is 8. So the probability that it would come up heads on all 3 tosses is 1/8. All right, let's look at the next one. It says a fair coin is tossed 4 times and it comes up heads each time. What is the probability that it will come up heads on the next toss? Does it ask for what is the probability that it comes up heads on 5 tosses? No. It's only asking for the probability of the next toss. So it doesn't matter what's already happened in the past. Forget about it. It's asking for, I'm tossing a coin right now, what's the probability that it's going to come up heads on this toss? It's 1 out of 2. Is it tricky? Yes, you have to pay attention to that. Let's see. I'm looking in the... So like number 6, what is the probability of getting heads, heads, tails, heads, heads? That's not like this last one. This is asking for the probability of 5 different tosses. So it's going to be, this is number 6. It's going to be 1/2 times 1/2 times 1/2 times 1/2 times 1/2. So that's going to be 1/32 for that one. So they didn't give you one of the ones that tries to trick you. An example would have been if they would have said that it came up heads on 5 tosses, what's the probability of it coming up heads on the 6th toss? Then it's only asking for the probability on that 6th toss. All right, so that's all of lesson 114. You're going to do the evens on 114. Now, on page 358, lesson 115, which you're going to do the odds on, you draw a polygon in a plane, so it has to be on a sheet of paper. Polygon is just a 2-dimensional figure. It's not 3-dimensional, so it's on your paper, on a plane. If you connect straight line segments, that forms a polygon. No curves, no openings, straight line segments connect to form a polygon. So the first one there is not a polygon because it has a curve. The second one is not a polygon because it has an opening. It's not connected all the way across. The third one is a polygon, but it's called a concave polygon because it has an indentation, okay, like a cave, right? They're calling this a cave, so that makes it a concave polygon. We typically don't deal with that kind of polygon. We deal with convex polygons that don't have any indentions or don't have any caves in them. All right, so this one is convex. All right, down at the bottom of the page it says names of polygons. Okay, most of these you probably already know. A triangle has 3, a quadrilateral has 4, penta has 5, hexa is 6, hepta is 7. Octa is 8. Remember, that's a stop sign. That's the easiest way to remember it. You may or may not know the next ones. Nonagon is 9. Okay, nona. Decagon. It's 10 years in a decade. A decagon has 10 sides. Well, these last two you may or may not know. One decagon is 11, and a dodecagon is 12. Okay? Anything above that, they don't give it a special name. They just call it an n-gon. And they'd tell you how many sides it had for the n. All right, next page, we have, let's see. Oh, down at the bottom of the last page, they draw a polygon that has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's an octagon. There are several different ways you can name that octagon, and they show you that at the top of the next page. You pick a vertex and go one direction, and don't skip any of them. So I could start with H. That would be polygon, H, A, B, C, D, E, F, G. Or it could be H, G, F, E, D, C, B, A. It could also start at any one of the other ones. B, C, D, E, F, G, H, A. B, A, H, G, F, E, D, C. Doesn't matter, but you don't skip around and name them in different orders. So on the top of that other page, it lists all the different ways that you could name that octagon. A lot. Okay? Now, if all of the angles in a convex polygon and all of the sides are equal, so equal angles and equal sides, it's called a regular polygon. Okay? So if it says it's a regular polygon, then you know it has equal sides and equal angles. All right. So a quadrilateral has 4 sides. If a quadrilateral is regular, all 4 sides are equal, all 4 angles are equal, what do we call that? We call it a square, don't we? Okay, so in the box on page, if I can read that, 359, it shows you if you have a triangle that has 3 sides, a regular triangle is an equilateral triangle. It could also be called an equiangular triangle because all the angles would be equal. Gives you a picture of a pentagon and a regular pentagon. A picture of a quadrilateral and a regular quadrilateral. And a hexagon and a regular hexagon. Okay, a diagonal is any line that can be drawn to connect any non-consecutive vertices. So if we have this pentagon, and I want to draw a diagonal. This is a side, not a diagonal. So this would be a diagonal. This would be a diagonal. This would not down here because that's connecting 2 consecutive vertices. That's a side. Okay, so that's diagonals. If we draw all of them for that polygon, there'd be one here, there'd be one down here. I think that's all of them. Okay, so diagonals connect any non-consecutive vertices, meaning vertices that aren't next to each other. Okay, next, a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. Okay? This side is parallel to this side. Only 1 pair. That's a trapezoid. A parallelogram, both sets of opposite sides are parallel. So this one is parallel to this. This is parallel to this. And it has 4 equal, the sides that are opposite are equal each other. So that one's equal to that, and these 2 over here are equal to this. A rhombus is a parallelogram that has 4 equal sides, and a square is a quadrilateral that has 4 equal sides and 4 equal angles. A rhombus, since it has 4 equal sides, that's a square, right? It has 4 equal sides, so it's also a rhombus. Okay? So a square is a special rhombus. A rectangle has both sides of opposite sides are parallel. They have right angles. And the opposite sides are congruent. So the long ones and then the short ones. So a square, if you look at it, a square is a special kind of rectangle, isn't it? It has all of these properties, but in addition it has 4 equal sides. Okay, next page. Congruence and transformation. Planar figures, namely polygons, but could be circles, anything that's a two-dimensional figure, are said to be congruent if they have the same shape and the same size. So basically the way I usually try to tell people is if you can cut it out and lay it on top of the other one and everything matches, it's congruent. All right? Otherwise it's not. You can see what a translation looks like. It just slides the polygon in one direction. A rotation actually turns it, so it's completely turning. And a reflection is like looking in a mirror. All right? If you put something in a mirror, it's going to reflect back the opposite. So if you have a line of symmetry or a reflection here, you have something like this on this side. On this side, it's going to look like this, isn't it? It's reflected over that line of reflection. Okay, well, that's all there is for lesson 115. So you're doing the odds on that, and if you will, just email me the following message. Okay? All right, I'll see you guys tomorrow.